Okay, so some warm-up problems here. Unfreeze. There we go. And here are our solutions. Let me enlarge that. Did anybody let any of the fractions throw you off?
No.
No? Awesome. That's what I was hoping to hear. There's the next couple. There's the next couple there. And the last one. Okay. How'd we do on these? Good? Yes. Number 4. So this was that property that we talked about last time in class. Do you remember that? Yeah. Okay. So all I did was change the letters out, just so that we see that the letters are nothing but a placeholder. And then again, threw some fractions in there, and I'm glad nobody let the fractions throw you off because they work the same way. So don't be afraid when you see a fraction. All right, so let's get into the lesson today. And all of the examples should be on the sheet that I passed around to you so that you're not frantically trying to write everything down. Okay, so we're going to look at some more properties of logarithms today and then actually use them in some solving. The 3 rules that I'm going to go over with you today, the product rule, quotient rule, and the power rule. I do want to make a statement that the B, M, and M are all positive and real in these. So I'll just put that here. M, N, B are all positive and real. And we also said that, oh, sorry, I used A instead of B. A. Okay, and that A, remember, cannot be equal to 1. Okay, so that applies to all 3 of these rules. All right, so our first one, the product rule, what we have is a log with the base of A, and then what we'll notice is for the argument, there's 2 terms being multiplied by each other, M times N. And so the product rule, this is the condensation of it, but we can also separate it into 2 separate logarithms. And so this would separate into log base A of M plus log base A of N. All right. Our second property is the quotient rule. Right. So if we're multiplying and it turns into the addition of 2, what do you suppose the division is? It's a subtraction, okay? So the numerator will remain a positive, but we subtract the denominator portion of it. So this splits into log base A of M minus log base A of N. And then our last one is the power rule. We've got log base A of M raised to the R power. The power rule states that we can take the exponent that's on the argument and pull it out and multiply it to the entire logarithm. So that R that's up here will move out to the front. This becomes R times log, bless you, base A of M. And then I don't know if you remember last class when we looked at that one property where we said, okay, if you have log base B of B to the, I'll just use a letter instead of a number. We'll put an M up there. Remember I said next time we'll talk about a property and it makes this property make more sense. It's that power rule, okay? Because then what happens is applying the power rule, this would turn into m times log base b of b. And what did we say a log is when the base matches the argument? It's always equal to 1. It always equals 1. And so that's why that property says this is equal to just the exponent part, because this becomes m times 1, which is m. All right, so again, that's one of those, those properties that I don't really commit to memory, as in, oh, well, if you have the base and the argument and there's an exponent, it's just equal to the exponent. I just know that the power rule applies, and you can always find it that way. Okay, so we are going to start by expanding some logarithmic expressions here. And so again, if you see the word expand, they're asking you to take it from the one logarithm that it comes in and break it into however many pieces it will break into. All right, so in our first example, I have log base 6 of 3x. Okay, so basically it's just 3 times x in the argument. And so I'm going to expand that into log base 6 of 3 plus log base 6 of x. And there's nothing left on this, so this one is fully expanded. All right, so in B, I've got log base 2 of x over 5. Right? And so now basically, because there's a fraction in the argument, that's just a division problem, right? X is the numerator and it's being divided by 5 in the denominator. And so what you want to think about is anything that's in the numerator should have a plus sign in front of it, right? And so I have an x in the numerator, so it's basically a plus log base 2 of x. And then because 5 is in the denominator, I'm going to put a minus in front of that log base 2 of 5. And then of course that plus in the front we don't actually need because that's understood, so we can take that off. So especially with these ones, when there's a division involved, always look back to the original, right? I look here, there's an understood positive in front of this one, and the x is in the numerator. And in the second term, that 5, it did come from the denominator, so it does have a minus sign in the front. All right, are we ready to look at C? Okay. What kind of log would we call C? There's a power rule in it. And then, is it natural log? You don't see a base. If you don't see a base, you know it's a base. You know it's a base 10, so it's called a common log. Okay. So we know it's a base 10. We don't have to include that in there. So I'm going to start with, we've got x being multiplied by y squared. So that's going to be my first step, is to just expand that part there into log of x plus log of y squared. Okay. And then we see that we have an exponent that's on that y squared. So we're going to apply the power rule to that. Log x, there's nothing more we can do with it, so that's just going to carry down. Log of x plus, and applying the power rule to the y squared becomes 2 times log of y. Yes?
So we always simplify the log when we can, and we just leave it like completely.
Okay, so we've got one more What's different in this one?
Fraction, but there's no A. There's two variables.
Two variables in the numerator. We don't have a base again, so this again is understood to be base 10. Okay, but yes, we've got two terms in the numerator and one in the denominator. All right, so starting with the numerator portion, I have log of xy, and then because 3 is in the denominator, I'm going to put a minus sign in front of it, so that becomes log of 3. And then I have to expand that xy also because those two terms are being multiplied. And so splitting those up, this splits into log of x plus log of y minus log of 3. So we end up with 3 separate terms. And again, look back at the original problem. X is in the numerator. It has an understood plus in front of it. Y is in the numerator. It has a plus in front of it. 3 is in the denominator. It has a minus sign in front of it. So these are pretty quick to check. All right, any questions so far? These are not bad, right? Okay, so for the next example, it's asking us to condense the logarithmic expression, okay? So these properties work in both directions. So now we're going to condense, meaning in our first example, it's starting us off with 3 separate logs, and we want to condense it as far as we can. So the first thing you want to make sure is that the bases match on all of them, right? And so in all of these, they're all a base 4. And since they're base 4, it does mean that we can combine it into one single log. Okay, so the other thing I want to look at is there's a plus sign in front of every single one of them, which means all the arguments are just going to be multiplied. And since I don't have a minus anywhere, I don't need a fraction in my argument. Right? So it's just going to be a straightforward multiplication of the arguments. So log, it stays as a base 4, and then we're just going to multiply 5 times x times y. And now we are fully condensed. Are we ready to look at B? Okay, so B has a little bit more going on, because what do you see in front of the first one and the third one?
3 and 2.
Okay, we've got numerical values in the front, those coefficients. So we're going to apply the power rule. And then we also want to notice that we do have a minus sign in there also. So that is going to mean that our argument will have a fraction in it. Okay, so starting with the power rule, to undo that one, I'm going to put that 3 on the x. So our first term becomes log base 5 of x cubed. Our second term doesn't have a coefficient in front, so that'll just stay as log base 5 of y. And our third one, we want to be careful with this one because there's a minus and a 2. Okay? So what I'm going to do is keep my minus sign here and only move the 2 so that this is log base 5 of z squared. And so I say, be careful with these because what you don't want to do is leave minus 2 in the front, or leave the minus in the front and then put a negative 2 as the exponent. Okay, so be careful with that. Okay, so continuing on here, again, because I have a minus in front of that log, I know that I'm going to have a fraction in my argument. So I'm going to put my log base 5, go ahead and make my fraction bar. Everything with the plus sign in front is going to be in the numerator. So x cubed goes to the numerator. there's a plus in front of the y term, so that y also goes to the numerator. And then there is a minus in front of the third term, so that argument goes to the denominator. So we get log base 5 of x cubed times 3 over z squared. All right. I'm going to do this the other way as well, okay, just so that you guys can see that it still works out. Okay, so again, that first term would have been log base 5 of x cubed. This would be log base 5 of y. Okay, now if I decided to take that negative 2 and put it onto z, what's going to happen to the sign in front of my log? Yes, it's going to become positive. So what happens is you would end up with plus log base 5 of z to the negative 2. So now there's a plus sign in front of everything, which means those three arguments would just get multiplied by one another. And so we would get log base 5 of x cubed y z to the negative 2. Exactly. But we don't want to leave a negative exponent, which means I would have to take that one other step here and move that to the denominator. And so I would get x cubed y over z squared. So do I get to the same answer both ways? Yes. Okay, so again, what I want you to be careful with is that you don't put a negative up front and then put a negative up here as well. Okay, because that's going to put your z squared in the wrong position. So just a little precaution there. All right, ready to look at the next one? Yep. Okay. All right. So on this one, I've got 1/3 times the quantity of. And again, when you see ln, what do we call that? Natural log. Okay, so 2 times natural log of x minus 4 times natural log of y. What do you think the first thing is that we need to do?
Multiply or distribute the 1.
Yes, we've got to distribute that 1/3 through. So 1/3 times 2, we would have 2/3. And then natural log of x, and then the 1/3 times the negative 4, so we would have minus 4/3 natural log of y. Okay. Yes?
Why would we distribute first?
Because we need to make sure that, because with the parentheses, we kind of have to undo the parentheses before we can put it all together. Otherwise, you have to do it at the end. Right? It's easier to put it in here. Okay, so I've gotten rid of parentheses. Now I want to apply the power rule. So our first term becomes natural log of x to the 2/3 minus natural log of y to the 4/3. And so again, I have a positive and a negative, so I know my argument will have a fraction in it. And so I'll do my natural log. The term with the positive in front is the x to the 2/3, so that goes to the numerator. And the term that has the negative in the front is the y to the 4/3, so that'll go to the denominator. That's it. Yeah. And so back to your question, you were saying, why do we have to do that first? Not necessarily. We could have left the 1/3 out here, and then we would have had natural log of x squared minus natural log of y to the 4th, which we then would have had this 1/3 here, and this would have become natural log of x squared over y to the fourth. And then we'd have to apply the power rule to all of it, and so we would end up with the natural log of x squared over y to the fourth, and all of this would be raised to the 1/3 power. So we'd still get there to the same place.
Thank you.
Okay. All right. So for this one here, again, we've got some pluses, we've got some minuses, and we also have some coefficients in front. Right? So first one, I've got that 2 log of 10. So applying the power rule to that will give me log of 10 squared. Minus the second one would become log of 25 to the 1/2. And then the final one, there's nothing to do with that, so it just becomes log of 9 still. All right, yes?
For the log 10 to squared, can you do like, because it's a common log, right? So then,
It is.
so then would it just be 2?
You could do that. Yep. So she realized that, hey, I've got a common log, so it's a base of 10, and I also have an argument of 10 with an exponent. So yes, if you notice that, absolutely, you can turn that into a 2. No, it's just 2 now. That's the value of it. Right? Because remember, this is going to be log base 10 of 10 squared. Yeah, which is equal to 2. So that would take care of that term there. And then we would have minus log of 25 to the 1/2 is, it's just, remember, if you're taking the square root of 25, can it be negative? No, it can only be positive. Okay, plus log of 9. Yes?
I understand that correctly? Why exactly do you sometimes have plus and minus and sometimes don't?
Okay, so the difference between when you get it is what you have to think about, are you starting with a variable here that you're solving for? Okay, because in this case, in order to figure out what x is, we would take the square root of both sides, and that means that x could potentially be negative, right? Because the original problem is starting with an x squared is equal to 4, right? So yes, you could plug in a negative there because that will give you 4, and you can plug in the positive there, which will also give you 4. So you're solving for an unknown, which is different than if you were just given what is the square root of 4.
So if you start with the square root, so it's positive.
Yes, yes,
Okay.
right. Because this isn't there's no variable involved here that we're trying to figure out. There's only one answer. Square root of 4 can only be positive 2. All right. Almost done with this one. Okay, so at this point, we've got 2. Let's see, how are we going to combine this together? What are we going to do with this one? Yeah, we've got, let's see, did we make a mess of this one? No, 2 minus log of 45. Okay. All right, what's going to happen now? This would turn into, this is still a base 10. I think we may have made this more difficult. I think we did. Because this now would have to be, we'd have to figure out what that is. And boy, we don't have many common bases here. Okay, I'm going to say that this was probably not a good idea. This one didn't work out so well. It's okay, no, I'm glad, but There is a value to it. So let's go ahead and, instead of turning that into 2, let's go ahead and combine everything. So we started with this. Make a little bit of room here. Okay, so that would have been, do a different color so it stands out a little more. Okay, that would have been log of 100 minus log of 5 plus log of 9. And then combining the ones that are in the front, or with the plus in the front, would go to the numerator. So we would have log of 100 over 5 here, and then the 9 would be in the numerator also because it has a 9 in the front, or a positive in the front. And then if we simplify this, we're going to end up with 20 here, which turns into log of 180. So they both should come out to the same value. Yes?
What is the log 9?
There is a positive sign in front.
Okay, so it's going in the numerator.
Yes, yeah. If you see a plus in the front, the argument should go to the numerator.
Okay.
Okay. Okay. Anybody want to plug that into your calculator and see if we get the same thing? Oh, you guys may not know where those log keys are. Okay, if you use just the log here, it's automatically going to give you a base 10, which is fine for this example here, which is 180. So log base 10 of 180. Okay, and then we get that number there. Oh, actually, that one's a log base 10 too, so it's okay. If you need to change the base of your log, what you do is go to your, let me make sure I remember this correctly, math key, and there we go. There's the button, log base. And that actually allows you to change the base. So anyways, this one is still a base 10. And we did a 45 here, which would be that. Why are we, oh, that's not the same, is it? 2 minus. Oh, I put in the wrong number, sorry. 2 minus. Did somebody see where we went wrong?
I got the same.
Oh, whoa. I put the minus in the front. I see it. Okay, let's do this. We subtracted the whole thing. Okay, you know what I'm going to do? I'm going to do this. I'm going to do plus up here. Woo, we made a mess, didn't we? This is kind of fun to figure out, though. Okay, so what actually should this be? Plus, this would be log of, that would be the 9 over 5. Okay, hopefully that works out. Let's see. We're having some log fun here. Okay, so this would be log of 9 over 5. Okay, there we go. And then it becomes 2 plus this. Do you see that sign? Did you guys see the sign error I made? Yes. Yes.
So if you do 10 to the power of 2,
10 to, yes, yes.
Wait, how do you get the bottom button for the log?
Oh, that's under the math key. And if you scroll down, scroll all the way down, then you can actually adjust the bases.
Oh, thank you.
Yeah. Okay. What was the lesson in that?
to check your signs.
Check your signs. Check your signs, exactly. That was a goof up on my part on the signs. Okay, but we figured it out. Okay. Next one. 4 for you guys to try. How about we get up on the board and work? Okay, so look like everybody was perfectly fine on this one. Log base 6 of 3 plus 4. Log base 6 of x. Okay. Ladies, this next one, this is where I saw the most mistakes. So always check your final answer to the original. So remember, when you're doing this, what's happening is you've got that. So when you separate those, it becomes the natural log of 5 minus natural log of 12 plus the natural log of x. Okay, you have to distribute that negative sign through. And again, if you don't want to write out the steps like that, just again, look at the original problem and look at where your what terms are in the numerator and what terms are in the denominator. Right? So again, 5 is in the numerator, so it should be a positive, which again, that's understood. 12 is in the denominator, so it should have a minus sign in front of it, and x is also in the denominator. So again, that's where I see the most common mistakes. Okay, everybody seemed to do fine on this one. Log base 3 of 7 over x. And everybody seemed to do fine on this one. First step was this, and then it became minus natural log of 3 squared plus natural log of 4. And we can just throw, again, 18 is a positive, 4 is also positive, so those both go to the numerator, and then 9 was a negative, so in the denominator equals natural log of 8. Okay, so the last thing we're going to look at today are solving logarithmic equations, okay? What fun stuff am I missing over there?
Sorry, I don't know.
All right, so if you had a logarithm equal to a logarithm, right, the arguments have to be equal to each other, right? But in this case, we've got logarithms on one side, and then we have this constant on the other. And so what that means is we have got to re-express this as an exponent in order to solve what x is. So we're going to use our properties, because in order to switch it into an exponential form, we need to get it down to a single logarithm. Right? So in our first one, we've got bases of 4 on both logs, so that means I can condense this into log base 4 of x times x minus 6, and that's equal to 2. Okay. So now that it's a single logarithm, I can put it into exponential form. So the base of the log is 4, and what would I raise 4 to the power of?
2.
4 squared is equal to, and then I've got the argument left, which is x times x minus 6. I'm going to go ahead and distribute that x through to get x squared minus 6x, and really, what have we just created? A quadratic. And what do we like about the quadratics? If we can factor them, right? If it's not factorable, they're not so much fun. But we get x squared here minus 6x minus 16. And is this one factorable?
Yes.
Yes. All right. This factors into what? Negative 8 and positive 2. All right, which means we end up with two solutions here. We end up with x is equal to 8 and x is equal to negative 2. All right, so the next thing would be to check and make sure that it actually works. All right, so if I plug in 8, I'm going to get log base 4 of 8 plus log base 4 of 8 minus 6 is 2. And we're asking, does that equal 2? So using my log properties, this becomes log base 4 of 16 And is that equal to 2? 4 squared equals 16? Yes. All right, so that one works. All right, and now I'm going to check my x equals negative 2, and I do log base 4 of negative 2. And do I need to go any further?
Yeah.
No. Why? The argument cannot be negative. All right, this is undefined. And so therefore we know that x cannot be negative 2, and our only answer is x equals 8. Yes?
So the solution would be undefined if, what are the terms?
If you end up with a negative argument in the original equation. Always look at the original equation. Okay. Here's our next one. So log base 4 of 100 minus log base 4 of x plus 1 is equal to 1. All right, so again, I've got 2 logs on one side and then a constant on the other. So I need to combine these, condense them into a single log so that I can apply the exponential form. So over here, I've got log base 4, and then there's a plus and a minus. So the term that's positive, the argument will go to the numerator, and the term that's negative, the argument will go to the denominator, and that's equal to 1. All right, so now that I have a single log, I can apply the exponential form. So this becomes 4 to the first power is equal to 100 over x plus 1. And is this a nice simple equation we can solve? Yeah. All right, so I can multiply both sides by x plus 1. All right, that's going to take care of that and that. And now I have 4 times x plus 1 is equal to 100. I could distribute that 4 through and solve, or what else could I do? I can just divide both sides by 4. Uh-oh, why did it just freeze up on me? My OneNote just turned off. That was weird. Okay. But it came back. All right. It deleted what I just did. Okay. So x plus 1 over there, x plus 1 over there. So 4 times x plus 1 is equal to 100. We divided both sides by 4 to get x plus 1 is equal to 25, which means what is x equal to? 24. All right, and we will go ahead and do a quick check to make sure that it does indeed work out. So log base 4 of 100 minus log base 4 of 24 plus 1 is 25 equals 1. All right, apply our rules for condensing. This becomes 100 over 25. Log base 4 of 4. And does that indeed equal 1?
Yes.
Yes, so that checks out, and there is our solution. All right, so one more I'm going to work with you, and then I've got one for you to try. Okay, log base 3 of x plus log base 3 of x minus 6 is equal to 3. So again, my bases are the same, so I know I can condense this side. So I get log base 3 of x times x minus 6 is equal to 3. All right. Take it out of logarithmic form and put it into exponential. That becomes 3 cubed is equal to, I'm going to go ahead and distribute my x through to get x squared minus 6x. And again, we ended up with a nice quadratic, which will set equal to 0 and hopefully be able to factor it. So x squared minus 6x minus 27 equals 0. And what does this factor into? X minus 9, x plus 3. Again, ended up with two solutions here, x equals 9 and negative 3. And are we done? Yeah, we need to check and make sure that it works. All right, so checking, I get log base 3 of 9 plus log base 3 of 9 minus 6 is 3. And is that indeed equal to 3? What's log base 3 of 9? 2. What's log base 3 of 3? 1. And yes, this works out. What's going to happen when we plug in that negative 3? It's going to become undefined. So in that very first statement where we have log base 3 of negative 3, again undefined, and therefore our solution cannot be negative 3, and we're only left with x equals 9. Okay, should you assume that if you get an x equals a positive and a negative, that automatically the negative doesn't work? No, you shouldn't. So be careful with that. Don't just assume that that's automatically the one, because it depends on what your expression is inside your argument, right? You may end up with an expression that's like an x minus a negative, because what happens if we plug negative 3 into the second expression? The log base 3 of x minus 6. That doesn't work. That was not what I meant. I was thinking the other way around. Sorry. Let me clear that up. What if we had, say, if it was flipped? It would end up a positive, and it would not be, it would still be defined. Okay, so be careful. Don't automatically assume that the negative term is the one that doesn't work, is the extraneous. Okay, here's one. Sorry, this one's not printed on your paper, so you'll have to write that down. So I'll give you guys a minute to work on that one. All right. So as you stated, this one does become 4. What was the other extraneous solution here? Negative 8. Yes, x plus 4. All right, 2 to the 5th. Okay, so again, I passed out for you guys a little mini worksheet that you can, that's in addition to the book work. And that's all. We finished really fast today. Yes, Catherine.